Okay, so what I'm going to do now, I've already done a few steps ahead of this, and because what I'm trying to do is actually show you what happens when you add acid or base to a buffer. So if I have this many milliliters of that NH3, so it's just the 0.200 times the 0.4, when I do that math, I'm going to get this 0.8 number. So that's one of the components of the buffer. That is in moles. Now, if I go to the other side, I have 0.2 times 0.2, which is 0.04. So the reason why I'm not saying this up as a reaction right here is that I'm trying to just show you that we have two parts. We have some of this one and we have some of this one. And once we know how much of each of those that we've got, we can use the Henderson-Hasselbalch. We can fill it in. So notice that my salt value, and it looks like I left a 0 out. So there's a 0 there and a 0 there, but it will give the same value, still 1/2. But you'll notice that the salt right here is going in, and then this is my base going in, and then this is the pH that we end up with from this buffer system. So that's setting of the buffer. This is the buffer that is existing. Now, what happens if we add an acid to the buffer? So there are two pieces of information you need to figure out. One, if you add an acid, which side reacts? And then two, how much is lost? So I'm going to add in 0.01 moles of HBr to this reaction. So first off, I'm going to zoom in on this. I've got an acid, right? Do acids react with acidic salts, basically acids, or are acids interested in bases? And what I'm hoping you're seeing is that acids aren't going to react with something that's acidic. It's definitely going to be way more interested in the base part. So what that means is that this side of the buffer is the one that's going to be doing the reacting with the HBr. Now, in contrast, I'm going to switch on over to our second case, and that'll be where we add our NaOH. Again, this is a base. It's a really strong base. Is a base going to be interested in acting with a base or an acidic salt? It's going to be interested in the acidic salt. So in this one, it's not going to be the NH3 side that reacts. It's going to be the acidic side that reacts. So I just wrote these as two. It's the same like equilibrium. I just reversed the way that I wrote it so that you could see them reacting. Now, you don't always even have to write it as a reverse, but I'm doing it this way. Like what I'm trying to say is there's a few ways of solving these. You might be able to find them on the internet if you're trying to find some different ways. I don't want it to be confusing to you. But I like to write it where it's like the reaction with whichever side that you're trying to deal with. So notice that in this one, because this is a base, it's reacting with the NH3 part. And I don't need, it's not in this direction, it's the other direction. Whereas up here, this one's reacting with the NH3, not the NH4 part, and I don't need this direction. So that's the first thing. You've got to just make sure that you identify where's the base in the buffer or where's the acid, what I'm adding, which side's it going to react with. So I'm going to go back up. I'm going to erase this a little bit below, and I'm going to put in how much I had to begin with that we already calculated up here. So how much I had to begin with was that 0.08 mole, 0.08 moles, and 0.04 moles. And again, like I said, I already decided which side it's going to react with. So it's going to react with that NH3 side. So I look at all those numbers. The smallest number is that 0.01, 0.01 minus 0.01. And then this is making this one. So what I have is 0.07 moles, and I have 0.05 moles. That's what I got. So now my buffer changes. Instead of being this number, let me grab it. Oops. Instead of having the 0.8 and the 0.4, now it's changed a little. And now I have This is my salt, the 0.05, over the 0.07. So when I put that in my calculator, negative log of 1.8 e to the minus fifth, plus the log of 0.05 divided by 0.07 is going to give me, instead of being the 4.44, which is what it was 4.59, basically 4.60. Now, I just want to point out something. We added a strong acid, like all of this completely dissociated. This guy's got a pH of like 1. Weird. So this one had a pH of like 4.5. I added, 0.01 moles. That's not shabby. That's a decent amount. And yet my buffer only changed by a little bit. This is the power of the buffer. What's really happened is that this HBr, he's given him the H and he's just making him. And the nice thing about a buffer is it can shift either way. Let's say I get a little high on this side. Then if some base is added, it will shift back to the other way. So this is kind of like taking advantage of equilibrium to the extreme. So let's see what happens to our buffer when we add the NaOH. So I'm going to go back up because my NH4 amount, when I started, this is the original, 0.04. I'm going to add in that same amount of this base, 0.01 moles. And originally, the NH3, I had 0.08 on that one. So when I do my ICF chart, I'm losing 0.01, and I'm gaining 0.01. So that tells me 0.03, that one's 0, and that's 0.09. So again, I'm going to grab my same Henderson-Hasselbalch, and now my numbers. My salt is my 0.03. My base is my 0.09. And originally I had that 4.4 number. So let's see what that 4.4 changes to now. So I've got, here's the same thing. And then I'm going to make that the 3. And this one is the 9. So now my pH has only changed downwards about, like 0.2 of a pH, even though I added a super strong base. This is an NaOH here. It's got a pH of like, 14. So you can see the pH or the POH in this section isn't changing. And I should clarify that. Note that this whole time I was solving for POH. And if we wanted to see the change for pH, it's not that hard. You would just do 14 minus the 4.44 and 14 minus the 4.60. And same for the lower one. I just kind of figured you could kind of basically see the point of it, which was that the pH doesn't change very much, even though we added like an extreme strong base, extreme strong acid, didn't change the pH very much. And that's the power of a buffer. So that's how you want to go about solving these problems.